All right, here's section 3.3 nomenclature. A lot of what I'm going to talk about right now is going to be review over the past couple of days. Again, it's nice to have this nice and uniform in your notes, and the more we can hear it, the more it'll kind of absorb into our brains and allow us to do a little bit of a review. So type 1 compounds. We define these as ionic compounds that contain a metal and a nonmetal, sodium chloride being an example. To name these things, all we're going to do is change the anion to ITE. So instead of sodium chlorine, it's sodium chloride. We don't mention the subscripts in the name. So for instance, if we were to have magnesium chloride, MgCl2, we do not take a look at that compound and say that's magnesium dichloride. No, just magnesium chloride. The 2 is implied by the known charge of the element. Type 2 compounds, a little bit trickier. These contain transition metals, and transition metals have a varying oxidation number. So transition metals do not all have a set number of valence electrons. We don't always know what their charges are, and the charges must be defined in the compound's name. So when we name the cation and the anion, we do that just like type 1. The only difference with this type of compound is that we go ahead and place Roman numerals in between the cation and the anion. So if we've got something like Fe2O3, we're going to call that iron. If you do our process, you'll find that that's iron 3, and then we name it the same at the end. So iron 3 oxide, which is this stuff right here. It's rust, actually. All right, type 3 compounds. These compounds that contain both ionic and covalent bonds. So Na and then the NO3 in parentheses. Here's a good example. The bond between the sodium and the nitrate polyatomic ion is ionic, but the bond between the nitrogen and the oxygen are covalent bonds. And so when we have this type of item that you see right here, that nitrate, that's going to be known as a polyatomic ion. And on page 127, you have the polyatomic ions that you'll be responsible for. And remember, we only listed 10 of those, so make sure you're making note cards of those guys. All right, the last type of compound that we really care about is a type 4 compound. These are actually, to be honest, the simplest. Although you have so many rules at this point, you'll get confused, so it's really good to practice these. These types of compounds, they don't have a metal. There's just no metal whatsoever inside of them. So they're real easy to pick out. There's nothing on the left side of the periodic table. Maybe hydrogen, but we know hydrogen's not a metal. So carbon dioxide is a really good example of that, CO2. If we're naming this, in this case we use prefixes specifically to denote the number of participating atoms. So a lot of you have been trying to use the prefixes di and tri and tetra when you're naming your compounds, and I've said, no, don't do that, we'll get there. Now is the time when we get there. Oxidation numbers really don't matter in the naming of these types of compounds. And we know the rules. We don't use mono with the first element, and we don't reduce the subscript. So why? Why all these new rules? Well, this guy right here, CO2, when we talk about CO2, we literally mean just a single carbon and 2 oxygen atoms. And that thing floats around independently all by itself. That's really different when you compare it to something like NaCl, sodium chloride. Sodium chloride is a mixture of sodium and chlorine atoms in a 1-to-1 ratio. And so that's what we're seeing with the formula sodium chloride. And so it's not just 1 sodium and 1 Cl, it's a billion sodiums and a billion Cl. So that's the huge difference between our type 4 compounds and all the other compounds, is the fact that the type 4 compounds we're really specifically talking about singular molecules. Now, just to be very complete, these types of compounds are known as covalent. We've also called them in the past, we've called them molecular compounds. And all the prefixes that we'll need are located down here in the lower right-hand corner. So mono, di, tri, tetra, and penta. There are more, hexa and hepta and octa and nona. Go all the way up to 10. 10 is deca. So if we have an example of like CO2, we would call that carbon dioxide. If we had an example of like N2O5, so 2 nitrogens and 5 oxygens, we'd call that dinitrogen pentoxide. All right, that's nomenclature.